Hello, distinguished colleagues. First of all, in the very beginning, I would like to extend my words of respect to the company Rakurs for the honor that they accorded us in allowing us to speak at this high forum. Distinguished colleagues, everybody knows very well that Russia is the largest country of the world. Also, everybody knows that Russia has the largest area under forests, about 1.4 billion hectares of wooded areas in Russian Federation. According to expert opinion, 300, 400 million hectares would be the forests in economic use, the so-called intensively used areas, where on a daily basis there is some economic ongoing activity, which includes the use of forests, protection of forests, and reproduction of forests. And in full accordance with the existing Russian legislation, all the economic activities in forests and the forest planning at the regional and local levels must be done based on the forest taxation data. The main problem here is that now the current demand for the updated materials and taxation are assessed at the level of 300 million hectares or 30 million hectares per annum. Can you imagine what is the size of this problem? And there are two bad things attached to that. This is a continually growing demand, and it is still unsatisfied. It is obvious that this major state-level challenge cannot be resolved by traditional land-based, expensive methods. For that, new approaches are in order. We believe that these approaches must be based on two mandatory conditions. First, Russia needs to do the transition from the conventional, labor-intensive, low-performance, land-based forest taxation to modern, high-performance and affordable levels. And they also need to establish a system for personnel training on remote sensing of forests. And our company, specialists from our company, have done a technological breakthrough in this area, because we have trained and developed, first of all, the modern technology of stereoscopic forest taxation, which is based on very efficient cooperation with our friends, because the first stage of this technological chain is done based on visual map A3. We are amazed at what can be done by this complex, both in terms of performance and the quality of output products, and that everything is automated. It includes high quality orthophoto plans and stereo pairs. And secondly, this is the instrument to interpret thematic interpretation of aerial photography, ultra high resolution photos. This is also a module of Photomod StereoMeasure. And the final stage of the whole technological chain is done with the use of our software, which is developed by the specialists and software developers of our company. Forest Book, ISAU. And also jointly with the leading scientists of two forest institutes of Russia, Volga and Russian Institute, we have prepared a complex of training materials to train specialists on remote sensing of forests. Now, the key aspect of the whole technological chain here is the StereoMeasure module. How did we arrive at that? Because just 4 years ago, when we just started on this, and when we studied the global market, unfortunately, we found out that the world doesn't have a single specialized software on forced thematic interpretation. After a long search, we found, or rather we stopped on the Photomod stereoscopic module StereoDraw. We have prepared terms of reference and received from Photomod a new specialized module for forest stereoscopic interpretation, StereoMeasure, with a broad functionality. And with this, we did first experimental and then industrial projects. In fact, the process of thematic interpretation for forestry is quite a complicated process, and methodology-wise, it can be subdivided into contour and taxation interpretation. Taxation interpretation is in turn subdivided into analytical and measurement interpretation. And at the first stage, the interpretation with the use of Photomod can be done through preparation of images and development of projects with implementers and raster layers, and improvement of the image, like color correction, geometric correction, histogram correction. And after that chain, we move on to the contour interpretation, which is a classical approach from simple to the more sophisticated one with number of stages. А как перевод? А перевод?
Я же говорю, ты один будешь.
And this way, the whole block can be subdivided into large generalized lots. All these stages are described in different rules. And finally, at the contour deciphering, we acquire contours or polygons of more or less rectified areas of wooded lots. You can see the whole procedure of allocation of wooded lots. You can see generalized lots and also the polygons for taxation, forest interpretation.
То есть ты можешь без 15.6 сваливать.
Various spectral properties of different trees allow to set and tune up color gamma to get image in pseudo colors, where each tree variety has its own stable and consistent color, meaning that we can rely not only on the shape of canopy and the structure of canopy, but the color too. So during the interpretation process, as we pitch circular, as we plot circularly motioned shape on them, we can calculate the composition, and we can see how many dry standing trees we have. So this way we can do the sanitary checkup. Unlike 20 years ago, there is a very convenient elevation measurement instrument. We can measure models, elevation model of different trees, and average it out for the whole story or the whole forest. Also, we can do stereoscopic measurement of closeness of forest canopy. So we can see if a visitor falls on the canopy, on the edge of canopy, and then we can apply equations to determine the main indicator of forest inventories, and that is the standing stock of wood. So we can reliably measure 13 indicators, which is more than enough for economic and forest inventory purposes. Based on the project results, we also receive a geoinformation database and photo documents that are very easy to use. We did half a million hectare area. You can load it up on your smartphone, and you can see the configuration of each plot with properties. 500,000 hectares, 45,000 forest plots. So you will be able to see, you will be able to track your movement as you walk through the forest. Manufacturing testing of this technology showed that we had the right to put forward accuracy requirements at the level of ground requirements, ground taxation requirements. Last month, we completed a very big project which we won in a tender. It's in Karelia, 500,000 hectares. So 45,000 relatively homogeneous forest plots have been identified, and an individualized profile, taxation profile, was put together. So it's all here. It's very convenient. The customer has checked or verified by random selection 77 sections. Now there are 104. And what did this verification show? There were no blunders in terms of dominating species. Age was fine. Composition coefficient, relative fullness, had systematic errors that did not exceed the ground length of forest inventory methods. So we formulated 8 evident advantages of technology, but they're obvious to us. The accuracy of remote inventory and taxation by terrestrial method are more or less the same. Seasonal productivity, since we can work around the year, is 2 to 3 times higher the terrestrial approach. Cost per 1 hectare of forest inventory is less. It's 2 to 3 times less. around 1.5 euros per hectare. Also, as output products, you have visually appealing maps, and the control system is very transparent. So you can do secondary measurement of any forest plot at any time. Of course, we continue to work with our friends from Rakurs. We stay in touch. And today, jointly with Rosles and Fork, we're putting together a statement of work to further develop this module. We're looking to expand the functionality. We run experiments with high-resolution stereoscopic space-borne images. We did this kind of activity 3 years ago, and we favored aerial photography back in the day. You can work with space images just as well. But when it comes to tree accuracy, space is not as good as we find satisfactory and guaranteed for our tasks. We also have a number of customers that look not only for inventory characteristics, orthophoto plans, stereo models, they're after digital surface model. Because often they have to build roads before forest inventory is taken. So we talked with Rakurs about it. So we're gonna use Photomod for that too. And we hope to get terrain models, but there are some challenges because there are areas where the canopy is peculiar. I tend to trust Viktor Nikolaevich. He says it is solvable. We are now using interactive mode, but would like to switch to fully automatic mode. We are fully aware that taxation process is impossible to fully automate, even though we've been struggling with this for 40 years. But if you know what a taxation ticket looks like, what parameters go into it, know how challenging it is. But I suppose some of the parameters can be entered automatically as far as height is concerned, canopy, diameters, and so on. We hope to continue to successfully cooperate with very advanced and just nice company, Rakurs. Thank you for your attention. Any questions? Thank you, Vladimir. So my question is, did you try using data from aerial laser scanning? It's all done automatically. I mean, you can look under the trees, even you can go into the ground. I will answer this. It's a standard question and a good one. You know, we have friends over at Metla Finnish Forest Study University. There is laser photo plot technology used there. So they conduct a forest inventory in Finland using this technology for 6 years now. But in terms of accuracy, it's not as good. It costs 3 times as much as ours, and I mean, for Russia it's not a viable option. We are aware of this technology, but my company, our company, is going the other way. We don't object to somebody coming up with a competitive technology. As Mr. Reisman said, they could provide us a scanner, mount a scanner. Then, of course, it would be accuracy breakthrough to determine terrain. But given the current requirements of the country, the demand is 30 million hectares per year. Finland does 1 million hectares per year by interpretative method. The price is €5 per hectare. Russia can't afford this. And given the sheer scale and size of Russia and the amount of work to be done, this Finnish technology doesn't work in Russia. I think this was a full, exhaustive answer. Well, if we don't have other questions, let's thank Vladimir once again.